And this is another way winding. So this is a series winding, and this is what magnetizing LM. So CLLC in my heading of the presentation. CLLC is nothing but capacitor, inductor, LM, another capacitor. I will tell you in the circuit only.
Isolation transformer usually 1:1.
Sorry.
Isolation transformer usually it is a 1:1 transformer.
1:1 transformer. Yes, 1:1. Here the purpose of transformer is to provide the isolation. If it is required, in case if it is required to convert the voltage from primary to secondary, you can do that also, but that becomes a complexity for the resonance operation. And these are the different types of connector what we use for the EV onboard charger. SAE 70 Society of Automotive Engineers. IEC is what International Electrochemical Commission, right? Yeah, IEC standards, CHAdeMO standards, and Tesla. These are the different type of connectors to be used for the EV onboard chargers. And the moment you connect onboard charger or charging to the vehicle, from that instant it never starts the battery. It will check all the process. It does the doctor business. You know what doctor does when you go to the hospital? He will check with the stethoscope. The moment you go, you don't directly inject, right? He will not. He will see the patient conditions. He will see, and then he decides what tablets has to be given, right? The charger will also do the same job. What it does, it will detect whether the connector is properly connected or not, or it is just mechanically holding but not electrically connected. In that case also, it will not allow the charger to charge the power or charge the battery. If it is mechanically conducted, whether only one conductor are connected or all three are connected, this business will be done by this control collar and proximity protection. So control collar, what it is, it will control the power flow, and proximity protections, it will take care of all these parameters, whether it is mechanically connected, whether one is connected, whether it is burning, whether it is sensing or whatever it is. So the circuit looks like this. EVSE is nothing but electric vehicle supply equipments, and here is the connector, and it is at the vehicle side. So with all these reference parameters in and out, if all are proper, means this is, yes, reference value is this much, then it is detected, yes, proper charger is properly connected. Reference parameter and actual parameter both are matching, it decides that it is connected. If there is a difference in the reference parameter and actual parameter, then it is not connected. It doesn't have a brain. It will take action only on the reference value and actual value of resistance what is coming. See here R1 and here also R4, R3. So it decides the values of resistance between the reference and actual value. If all are matching, then it will do the further job. See, this is one graphical representation of complete charging process from starting to end. Let's say I am putting an electric vehicle charging at the night, evening. Morning I will remove the charger. So by that time what has happened? See here, in the first stage, there are so many different stages. It connects, it detects whether single phase power, three phase power, whether frequency is 50 Hz or 60 Hz. Whether it is under voltage power or over voltage power for protection purpose. It all decides, and then it will give the height decision from control quality is height from this point. Is it visible? CP is visible for you? Here it is. I think it is blurred. Okay. Then after that, once it is okay height, then next process will start. Then next process will start. Then after this, battery will start at this element. See, it's a charging current, constant current, reduced current, and stop. That is what I put the battery charging profile. Here the current is abruptly increasing. It is constant voltage mode, constant current mode, and trickle mode. Then it will stop. So this profile. Then where is the battery voltage? I am also not able to see. is what the battery voltage from 0 to maximum increased and remains high. Sorry, this may not be the battery voltage because I am not able to clearly see. Yeah, hope you understood this. From the complete process, it will detect all the parameters. When set all the parameters, all are being okay. From that point onwards, the battery charging starts. See, the instant of charging connector is here at this point. It has checked all the conditions. When all are okay, then only it will start the sending current. Let's say your son or daughter, while playing near to the electric charger, if suddenly he or she removes, then what should happen? It should be completely isolated. There should not be electric power when the connector is removed from the connecting plug. Otherwise, child will never know that it will do a touch. So for that also, there is an algorithm. If it is disconnected from the terminal, the power which is available in the terminal of, like there, it is isolated. That is how the protection. Otherwise, it is highly impossible to sell the components in the market. Forget about Indian context. If you take European context and American context, there they give very high priority for the safety. Very, very high priority for the safety. They don't allow any hard and fast rule to execute the process. And this is on and off board charger. As I told, on board charger is nothing but the charger which is inside the vehicle and off board charger which is outside the vehicle. Fundamental process remains same. There is no change in the process principle. Maybe power value can increase, maybe current value can increase, maybe voltage value can increase, but operating principle remains same. If you see this circuit, I hope if you can see this also, it's a conventional onboard charger, EMI filter is there, then 3-phase AC to DC converter, DC to DC conversion, then you are connecting to the onboard charger. This is what conventional grid charger is, means fast charger. And charger which is there inside the vehicle, it has also got EMI filter, power factor correction circuit and DC-DC converter, and it is connected to battery. But when it comes out of the vehicle, communication, how does the communication happens between the charge controller and the BMS which is sitting inside the vehicle? That's a CAN communication. How it matches the parameter with the outside charger with your programmed vehicle inside. You are connecting somewhere unknown connector, it gets interfaced with that and decides the SOC of the battery is very low, it will go for fast charging. So again, that is like if you are very particular in that, you can do a lot of work in that also. So there is a similarity between the fast charger and slow charger, as you can see here. EMI filter, power factor correction circuit and so on. So all will happen within the vehicle, but this all will happen outside the vehicle, and we are giving direct DC power. When you give the direct DC power to the battery, this onboard charger should be bypassed. There should not be any power flow from the onboard charger. So otherwise, the onboard charger will also get spoiled. And how many DC-DC converters are there in electric vehicle? This is one auxiliary battery, main battery module. Main battery is nothing but lithium-ion battery, and auxiliary battery is this low voltage battery, lead acid battery, which is used to power up all the interior components, wiper, then air conditioning system, then headlight, rear lamp, horn, indicator, or whatever it is. So all these are used with the DC-DC converter. So let's see, there are the different types of DC-DC converters. Now, the biggest challenge for me is in current organization is I am working with a mechanical engineer. So I am almost electromechanical engineer. It's very hard to make understand a mechanical engineer DC-DC converter. And they are very much irritated with voltage, current, power factor, then harmonics. They don't understand. They only understand crankshaft, camshaft, CAD-CAM. So for them it is okay. What you can call imagination, electrical is imagination. Mechanical you can see with the vision, but how to make them understand DC-DC converter. DC, we don't know what it is, you don't. I took these examples. For buck converter, boost converter, for push converter. See, that is a pipe. The quantity of water flowing in the entry level and exit level remains same. Only thing is pressure changes. Outside pressure changes. Here this side pressure reduces. In DC-DC converter, power remains same. Only thing is voltage or current changes. So in buck converter, the input voltage is greater than output voltage and current is opposite. Power, in order to match the power, we need to play with these two parameters only. So this is boost converter. Your input voltage is less, output voltage is high. And one-to-one converter. So here just for, we don't want to do any voltage deviation, but for the isolation purpose we may use. Then buck boost converter. So combining these two. Then dimag ki batti lagi. So these are the kind of innovations or R&D we need to do to make the unknown person to understand electrical stuff. Now these are the few examples. So with the input voltage, when we take, this is what, yes, now we understood. So industry environment is like that. So even you can teach this to the students also, just to understand. Hope you understood this with this pipe analogy also. Madam? You gone in silent mode. Are you with my presentation? Oh, thank you. Now next one is power electronic switches and their selection. See, as I told, selection of the component is very important. If you don't select the components properly, definitely we are landing in trouble only. What are the types of switches we need to select in the converters, inverters, as well as DC-DC converters? That is decided on the switching frequency and the power what they can use. Nowadays, these power converter switches are used in many applications. But what is the frequency of operation, what is the power density of operation, that needs the size of the components. If your frequency is very high, the size of the component reduces. At the same time, power density will also reduce. To optimize these two, nowadays the SiC and GaN based technologies are coming to optimize both the frequency and the power parameters to the maximum level. So for wind energy, so you see that for the robotic application, for electric vehicle applications, you need to select the high frequency operation device and moderate power switching devices, because size of the component should reduces. If you take high frequency, the size of the component reduces. In rail technology, if size increases to some extent also fine, because their size it doesn't matter. But switching frequency is very low. If switching frequency is low or operating frequency is low, then the size of the component should be bit bulky. This can be used in cargo ships also. That's not a problem. So this is how we need to optimize and select the components. And where are the places the DC-DC converters are being used in electric vehicle? If you take this schematic as a electric vehicle, from HV battery to LV battery, we need to transfer the power, because here there is no charging mechanism like conventional car it is happening. There is a synchronous generator in the conventional car, diesel and petrol car, which will charge the auxiliary battery, thereby all interior components are operating. But in case of diesel electric vehicle, it is not there. So in case of electric vehicle, it is not there. So what it has to happen is, either this can be charged from the regenerative braking system, or it can be charged from the HV battery charging time, or it can be charged from the HV battery alone also. So that is the reason the HV battery and the LV battery are connected with the bidirectional converter to exchange the power with isolation. Why? Because HV batteries are high voltage, LV batteries are low voltage. There should not be any hazardous happen when there is a power transmit from the HV battery to LV battery. And this is how we are providing from HV battery to LV battery with the isolation transformer. Again, this is the same thing, but how does it happens? You may ask why to DC-DC converter, why you are using a transformer, since our transformer is a AC device. In yesterday's interview, I took an interview for yesterday's one candidate who has got 8 years of experience. In DC-DC converter, how you vary the voltage? Sir, you can use a transformer. Yes, of course you are correct, you can use the transformer. But the purpose of transformer is what here? It will convert high voltage to low voltage. Can you use direct DC current to the terminals of the transformer directly? You just connect a DC power supply to the terminals, primary terminals of the transformer. What happens? Low voltage will convert. It becomes a mission Kashmir. Right? It becomes a bomb blast. Right? It won't sustain. See, that's the fundamental. But here, even though we are using a transformer, but at the terminal of the transformer, it is a AC one. It's not DC. May not be a sinusoidal AC. It's a square wave DC. At one instant of time, we need to turn on this switch. Other instant of time, we need to turn on this switch. So that ultimate the current flow at the terminals of the transformer is bidirectional. So if it is like zigzag bidirectional manner, then transformer will work as per its operating principle and also give the same output. The same output can be rectified and taken into the outside level. Here also you have switches, here also you have switches. Maybe uncontrolled switches, but operating principle at the transformer level is AC only. And this is one reference.
At any point of time, you can have any one of the switches, if it goes out of order, how the
damages.
Transformer will damage it or the circuit will stop
Out.
operating?
Like if switch is okay. If switch fails, then it may act as an open circuit or it may work in only one cycle. If usually what happens is there should be some time delay between these two switches. If both are exactly operating after one another, there is a dead end current or it may lead to a short circuit. That is why there should be some time delay in terms of milliseconds or microseconds. There was one project came when I was in L&T Technology Service. Washing machine project. It was wobbling all the time. Washing machine was doing like this. That came as a project. Customer also didn't understand what is the problem is. But when it came to the engineers, they charged huge amount for that to solve the problem and taken a 6 months of time. We resolve this issue and give it back. But it is just one day work. See, this is how the companies will make the bill payment. 6 month bill for almost 25 to 30 engineers for hourly base. Maybe in terms of crores, I can say, crores or lakhs. I don't know, it is at the background story, but it is huge money. And solution is just one day. You know what was the problem? In the inverter side, there was too much delay in the switching operation. When there is a too much delay, what happens is your continuity of sinusoidal will not happen. That means one positive phase, it goes to zero, negative phase goes to zero, positive phase, negative phase. That is where the AC motor is not getting the stable sinusoidal voltage, it's get wobbling. And problem is simple. So one day they are solved, they are made. So at the same time, it should not be too much delay and it should not be exact zero also. It may lead to a short circuit of the transformer itself. Same current may flow in the opposite direction and leads to the spoil. Your point is, if any one switch fails, either top switch or bottom switch, either it can act as an open switch. If it is not functioning, this transformer may only work for half cycle. If both fails, then it may not operate. I think I have answered your question. And how does the waveform look like in a DAB? DAB is nothing but dual active bridge. So dual active bridge is, it's a both bidirectional, in forward side as well as a reverse side. And if you see the waveform, let me do one single experiment over here. I am just not connecting this transformer. Imagine this is just straight line. Imagine top is also straight line, bottom is also straight line, and you are sending power from here to here. So S1 and S4 and S3 and S2 are simultaneously operated. S5, S8, S7, S6 need to be operated. And see the waveform how it comes. The switching sequence of S1 and S3 and others, they are not coinciding one another. They are different. When S1 and S4 are high, S2 and S3 are low. When S6 and S8 are high, S7 and S6 and S7 are low. And the overlap time of those two, this particular time, it's a 0 only. One second, let me. Yeah, overlap time here, these two are okay, these two are. Yeah, it is a 0 only. V1 is what? Voltage across the terminal of primary transformer that we are getting. When that is the input voltage at this side at V2 almost remains same except the delay in this period. See that? You can see this particular period there is a delay. It is shifting by some angle. And the current ILK is nothing but the load current here. So in this phase only it is going to change. Whereas during all the high phase, that means when switch S1, S2, S3 either they are high or low, then only we will get the load current. Other than this, there is a change of what you can say is phase from plus to minus. Hope this is a bit complex, right? Not complex, it's very easy. Only thing is we need to scratch our head for some time. Don't become like me. So I lost my almost all hairs. So these are the different converters and the testing. This is another laboratory test what we did in Europe on the same charger OBC with frequency and gate signals, as well as we saw the three-phase resonance operation of the LLC converter. And again, when does the transformer give the maximum efficiency? It doesn't give the maximum efficiency at full load also, 80% of load, because core loss equal to copper loss. Whenever the core loss is equal to copper loss, then only the transformer gives the maximum efficiency. If you overload the transformer also, it doesn't, because copper loss will increase. If you operate at lower load also, it operates at lower frequency because core loss will increase. Lower voltage or lower load, core loss increases. So to optimize those two parameters, we are operating the transformer where it gives the maximum efficiency. This is what the tested results, real tested results, and it gives the efficiency, maximum efficiency at the 80% of load. Beyond that, you should not do that. Otherwise, efficiency gets reduces. So this is about the core topic which I quoted, the LLC and CLLC converter. And these are the different testing. It is just like a closed box and very dangerous. We are operating with the 11 kV voltage at the circuit board level. And this is how the DC-DC converter looks like. I'll go to the next topic. Now, it's a system engineering. System engineering is nothing but all the components starting from source to destination. System means entire system. So what are these differential gears? Have you heard of differential gears? I hope many of you drive the car, right? If there is no differential gear in the car, what will happen?
Performance will not
If there is no differential gear in the car, you will not go 1 meter also on the road. Not 1 meter, maybe 50 meters you can go. 50 meter also you cannot go on the road. After 50 meter, what happens? You will go on the, you will go out of road. Why? Because everywhere road is not a straight. There is some right, left swirl. RPM of the wheel changes. Front wheel has to change RPM. When it is going left side, right side RPM will changes. More left wheel changes more. That is only possible with the differential gear. Otherwise, if both are rotating at the same RPM, it will take us to gutter only. Right? And if there is a jam of differential gear, then also your car will take us to, means it will go to the out of road only. So these differential gear, when it comes to electric vehicle, it is very easy to incorporate. I hope you might have seen a kind of box at the base of the axle in the lorries and trucks and bus. So this is what the place where the differential gears are placed. With that differential gear, it always tries to remain on the road. Don't ask front wheel. Front wheels are separately connected. Only it's a back wheels. And for car, it's a front wheel. Back wheels are independent. So in electric powertrain, the differential gears are incorporated here, as you can see this. So because of that, car can able to sustain, or car can able to work only on the road conditions. So speed control of car. How I think you have done the electric power electronics laboratories to control the speed of motors with powers, SCR. Speed control of induction motor using SCR. Like this, you have done several experiments. So what will be vary there? Frequency will vary. Ns equal to 120 by P. Simple equation. So Ns, if you change the Ns, your frequency will going to change. Sorry. Frequency if you change, Ns will going to change. Ns is changed, then you can play anything. Right? So this is a simple topology where you are changing the speed of motor with PWM strategy also, with SV PWM also, with trapezoidal also, with the selective harmonics also, with vector also, and many things, just for the smooth control of the motor. And this is how the field oriented control, FOC we call, when you change the switching operations. Now, when you change these sequences faster and faster, this will also rotate at faster and faster. Just these sequences, yeah. First, second, third, it is shifting. If you do it faster and faster, it will rotate at faster and faster values. That's why if you change the frequency of the switches, your output voltage will also change, output frequency will also changes, thereby the RPM will also changes. And block diagram of electric vehicle. To control the speed of the motor, so it's a closed loop control strategy. You have only accelerator in the with your control, and brake will be there. Either you can increase or decrease the frequency or voltage to the induction motor, thereby you can control the speed of the car. How does it happen at the back end? Nowadays, the cost of the vehicles are increasing, not because of the cost of the components. It is because of the high engineers' paid salary. If an engineer is got selected or recruited, he will get a 50 lakhs package, 60 lakh package, 70 lakhs package. Why? They want to have these solutions. And these costs will be bared from the customer high-end vehicle. You will see what is the difference between base end and high-end vehicle. Almost 4 to 5 lakhs. In one vehicle, 4 to 5 lakhs. To whom they are paying? They are paying to the engineers, those who develop the programs, those who incorporate the stuff, technical stuff. For them they are paying, not for this. So this is how the gear ratio, wheel radius, it will calculate all these things. and it also checks the current status of the electric vehicle, how it takes the reference parameter and actual parameter and decides the switches. That is nothing but the switching frequency to this voltage source inverter. Thereby, the speed of the induction motor changes. I'll go a bit fast. So again, these are the selection of switches for different applications. Now next one is braking. Every vehicle should have a brake. If there is no brake, you cannot take it out, and it is not to do also. So apart from brake, there is one more brake, what is called as regenerative brake. Where is it required? Is it required for electric vehicle or is it required for conventional vehicle? Electric vehicle. Yes, of course it is required, and also it can be used for hybrid electric vehicle also. Now, this regenerative braking system will never completely stop the vehicle. It can slow down the vehicle speed, but for completely stopping the vehicle, you need to have the mechanical brakes. So, and that too for what duration it is. If at all you are applying the brakes, usually it is in the seconds, maybe maximum 5 to 6 seconds you can apply. Even you may not apply in minutes. Did you experience how long you use the brake at one time? It's seconds only. 2-3 seconds, exactly. So within 2-3 seconds, the energy harnessed with the regenerative braking system, that is not possible to send to the battery, because batteries are like a electrochemical device. It has to convert all this process in second, it won't. So that energy can be dumped in the supercapacitor, because supercapacitors are like a bucket, as I showed the example in the beginning. So you can pour the quantity used and you can take out from this. There is no, there is a what is that? Field is called as dielectric field. So capacitor can be able to take that power and slowly you can discharge. Either you can discharge to drive the motor, or you can discharge this battery from supercapacitor to charge the battery itself. Again, it depends on the type of DC-DC converter what is being used. So this regenerative braking system is incorporated in electric vehicle along with all these braking systems. Hope you heard of anti-lock braking system. Have you heard of? Yes. What is anti-lock braking system? Nam kade ಒಬ್ಬ ಹೇಳಿದ್ರು ಸರ್ ಅಂಟಿಗೆ ಹಾಕ್ತಿರ್ಸಿದ್ರು ಬ್ರೇಕ್ ಮಾಡಕ್ಕೆ, anti-lock ಅಲ್ಲಪ್ಪ, anti-lock. He told, just it's a funny. Anti-lock braking system, how does it work? It never locks the wheel. Once you apply the brake to the car or to the two-wheelers, wheels can rotate like this. It will make, hope you got the sense. It will completely not lock, it will go in this way. That is what the anti-lock braking system is. So this anti-lock braking system is applied only when the vehicle is running at high speed, not at the low speed. Why? Because to avoid the skidding of vehicle, when you apply the sudden brake, vehicle has to decide, I am running at high speed. Then who will detect that? There is a speed sensor which detects the RPM of the wheel. So it depends on the RPM of the wheel, it decides, do I need to go for anti-lock braking system or I need to go for normal braking system. Anti-lock braking system is normally during the high speed operation. And when the vehicle is running at 10 kilometers or 20 kilometers per hour, anti-lock braking system is not required, because at that speed vehicle will not skid also. Are you all understanding, sir? Yes. Hope you are all understanding. So at that speed it should not. And also it has to go for regenerative braking system. See the complex algorithm which is there inside the vehicle will get confused. When you suddenly apply the brake, whether I should go for regenerative braking system, should I go for anti-lock braking system, or I should go for normal braking system. Who will decide? Driver will never decide. Only driver can use the paddle. Now, with all this, anti-lock braking system incorporated along with the control unit, how does it works with this? Sorry. There was one more. Yes. Now, this is what the knowledge-based algorithm. Anyone are student here? This is scholars. What is your name?
Ayub.
You are MTech? Are you married? Oh. What's your name?
Ayub, sir.
Ayub. Okay. I'll take the Ayub example. Ayub is driving electric car at a speed of 100 km and on the road at a distance of 100 km, Katrina Kaif came. So what is important for Ayub? Whether to save the Katrina Kaif or regenerative braking? To save the Katrina Kaif. For him to save. Now point is, when a person is standing at 100 km distance, you apply the brake very abruptly, very suddenly, very fast. Then this knowledge based algorithm has to decide this person is in the urgency, I need to bypass the anti-lock or regenerative braking system, I need to go for normal braking system. Otherwise, you will kill her. If at all with that brake, if you go for the slower braking, definitely it will not. It depends on the pressure what is being exerted by the driver. So this algorithm will take care of the braking system, either to go for normal brake or to go for regenerative brake or to go for anti-lock braking system. Now, what should be the algorithm? See here, algorithm, you know how difficult it has to take all the parameters as a reference parameter. If pressure is within that limit, this, if that is why software engineers are getting so much, and they will become mad before 51. Means, sorry, why I am saying is, they are involved in that, if they are dedicated. So, it's 1,000 and 1,000 lines of program which decides all this knowledge-based algorithm to decide this what braking system. Sorry if I am using any word, please excuse me. And now coming to the next other system, wiring diagram. Wiring diagram is nothing but how power is, simple wiring diagram it is. And there is a Pokayoka connection we call. Pokayoka connection is a Japanese word. It never interchanges the connectivity of two conductors. Plus and minus should never be connected to minus and plus. So that is what we call it as Pokayoka connection. In electric vehicle, it has to be a very particular, because instead of connecting plus minus, instead of going forward, it will go backward. Means this may happens. So, and this is what the simple wiring diagram. From the main battery supply, there is a connector, your key, which makes the connectivity of main battery power to the controller, then your brake panel, sorry, accelerator panel and motor. So motor decides the speed, and there are the other auxiliary components. And if you see the complete diagram of wires, it is just like a human body. See, human body is, you know, with complex nervous system, circulatory system, all systems are there. Sensing, everything is there. That's why God has made so nice that we can live up to maximum years without affecting any performance. This is what the circuit of all the components, majority of the components, including charger, battery, then protective switches, then control inverter, then motor, then dashboards, and so on. Next one is battery management system. So, till what time I can? So, another 5 minutes. I will quickly finish. So, battery management system. Hope you are aware of it. All of you are aware of it. But I will make you in a different way what battery management system is. Before battery management system, you understand self-management system. Why I am saying self-management system is human beings have different parameters, air parameters, dress parameters, making yourself, all these parameters I can talk. If you are not limiting all these parameters well within the limit, what happens? Instead of human being, you may become a old age man also, or cave. The human beings which are living in the cave have long hairs, they don't do anything. So what I am saying is, if you don't keep all these parameters well within yourself, then your management is not correct. So in order to manage all the parameters for the battery, so there are the different parameters of the battery need to be kept well within the limit. If you don't keep well within the limit, what happens is battery may go off or battery may catch fire. It is just like a thought process. Battery management system is an embedded system. It includes both hardware and software to integrated hardware and software which performs according to the battery parameter changes. Best example I will tell you. There is embedded system is sitting in all of us house. Refrigerator, temperature controller. Temperature controller in a refrigerator is an embedded system. Otherwise, all 360 days your refrigerator will be on. It will sense the temperature and cut off and cut on. Power on and power off will happen. Depends on the temperature. So this BMS, I don't want to take much time on this. Yeah, one particular parameter, what is called as cell balancing. So all this, as I told, there is no single cell which can provide a power at a high voltage. So all these cells are connected in series and parallel configurations to get the desired level of voltage. If at all you develop one cell with very high voltage, BMS is not at all required. It is a patent. Now, since all these cells are connected in series parallel configuration, even though these cells are from the same manufacturers, because of small defect in the chemistry of the cell, they don't charge simultaneously or discharge simultaneously. Uneven charging and discharging will happen. So if there is failure, let's see this is completely empty, then this particular cell complete cell may act as open circuit. And one may fully charge. If you fully charge, after that also you are sending current, it may overblast also. So if there is failure of any string in this entire, leads to the failure of whole system. That's what I mean to say. There is one string which is failing. So we can do active cell balancing and passive cell balancing it is. So again, that is a topology. It is as good as transferring the power from neighbor cell to other cell which is overcharged. So that is what active cell balancing. Passive cell balancing is whichever cell is overcharged, you can just discharge with the cell through a resistance. By connecting the external resistance, you discharge the overcharged cell. That is what the passive cell balancing is called. And why it is required? Cell balancing is required to increase the battery lifespan, to enhance the battery performance, to maintain the cell temperature, to overcome the hazards. And when to do the cell balancing? Is it required during the running operation, or is it required during the charging operation, or is it required during the hard condition? And also, what is the difference of the voltage between the neighbor cell to another cell? Whether it is a 5%, whether it is a 10%, whether it is only 1%, then it may not be required. If it is 50%, then it is abruptly required. So these are the different times you can perform the cell balancing. That is a cell balancing topology, so which detects the cell voltage across. Then thermal management system. So even though we are not burning a fuel in case of electric vehicle, but still we need to maintain the temperature well within the limit. So this is what African elephant I have shown. How does it maintain its body temperature now? The ears, exactly. So its skin is quite thick. The blood gets circulated through the ears and it will get cools and again it's just like a transformer fin I can call. Right? So the similar operation is radiator. Radiator is there with the current conventional diesel and petrol vehicle, since we are burning a fuel high temperature. But still radiator is required for electric vehicle also, even though we are not burning a fuel. Because there are some places where temperature increases in the charger, in the inverter, in the BMS and in many places. So this is how the thermal management system is used for the conventional vehicle. In olden days, they used to use a water. Nowadays, coolant glycol is used. This will increase the operation. Performance also increases. At the same time, rusting operation will also be minimized. So these are the simple battery connected in series and parallel. How does the temperature maintain well within the limit? So this is for Tesla vehicle I am talking and Nissan Leaf. And battery temperature management system. So one of the questions asked by the morning, even though battery is very dangerous, but still we are using. Yes, of course they are dangerous, but with all the proper protection, we can use battery, lithium-ion battery for the electric vehicle applications. This is what the BTMS, battery temperature management system. So batteries are like a human beings. Why I am saying batteries are like a human beings is, if the temperature of human beings or man or like it goes to 0, then also it is danger. If it goes to above 100 or above, also it is dangerous. Same thing, batteries need to be maintained well within the upper and lower value of the temperature. So if exceeds because of overcurrent, it may fail. And in cold countries, it requires a reverse operations. It need to be heated up. If minus temperature goes 5, 6 or 7, 10 degree, 15 degree, then it has to be heated up to retain the battery charge. So that is why this battery temperature, your target temperature is nothing but you can give the reference value of the temperature, what is the upper and lower value. So that decides a battery, protections, a temperature. And for the power electronics components what we have used in electric vehicle, the heat sinks what we use, they must be sophisticated. They are not like a conventional heat sinks what we use in the laboratory. Even though being a smaller in size, they should do best job. See the complexity of the heat sink it is, how it is designed. If the air passes in this from entry to exit, definitely it will get completely cooled. And why I have shown a baby? Yes. Why the baby is shown here, you can regulate your body temperature by keeping the muffler on the ears. Now you can do this in winters. If you are getting too much cold, so that your body temperature is not exchanged with the environment. But here it is reverse process. You should not do the same process. You should do the opposite process in order to have the better cooling. Right? I am just putting the reverse analogy. Okay. And these are the different cooling systems which we incorporated for the mechanical systems, for the battery on battery management system, and battery disposal. So till now we have not reached to this stage. One day may come. The battery disposal itself is the biggest challenge, but the recycle of the batteries can be done in order to minimize the battery exposure or battery waste. You can use 50% of the battery waste and reuse it for the operations. There is a proper cycle of battery disposal that can be used. Yeah, as I told, there are some places it requires to heat the temperature, heat the vehicle. This is what the Tesla S model. Now it's almost minus temperature. You need to not require to cool here. It requires to heat the vehicle. Next one is aerodynamics of the vehicle. So aerodynamics is what it is. Yeah, what is the train I have shown? What is the train is name? What is the name of train?
Bullet train.
Yes, of course it is bullet train. But name of the train is Shinkansen. You can Google it. Shinkansen is the Japanese train which runs at 450 to 60 kilometers, almost 500 kilometers per hour. So when I was traveled in this train from Tokyo to Fukuoka, I can't able to count the number of poles going back. The wiring, the catenary poles, I can't, it's that much of high speed. And there was no vibration also. The water glass or whatever the bottle you keep, there is no vibration also. Why? Because of its aerodynamic nature. Even though the train catches high speed, its rail grip is going to increase. Because you see the structure of the vehicle in the front side, when it increases speed, it presses it down. Means it presses the vehicle on the track. Reliability with the track is also increased. That need to be done with the electric vehicle also. And it is just like a shaft. Shaft, again, it's a body shape if you look now. It is required to do it for electric vehicle also. If you do it like this, nobody will purchase the vehicle. Of course, I may be putting all my pressure, all my efforts and manufacturing very high efficient electric vehicle, but if no one is purchasing, then what is the use? To retain in the market, what we do is to attract the customers or to rely in the market. We go for these different types of aerodynamic structures of vehicle and we do the testing. This gives a better efficient, better aerodynamic performance, and we go for this vehicle. This is one student project where they got the prize also, and with the aerodynamics for the racing car what they have done. Sorry? Yeah, it is a FRP sheet. It's a transparent. Means it's a kind of thick material which can be changed the shape by hot air. If you blow a hot air on this, the shape could be changed. And what is the CD? CD is nothing but coefficient of drag which decides the aerodynamic performance. In older days, the shape of the vehicle was like this, and the coefficient of if the vehicle is shape of like this, the coefficient of drag is 0.05, 0.013, 0.015. So better we can go for this type of vehicle in order to have the good coefficient of drag